Hello guys, welcome to our second day of Unit 1. So on the first day we talked about our polynomials. We classified them by their term and their degree, and then we also added and subtracted them. So what we're going to look at today is we're going to actually look at multiplying our polynomial with another polynomial. Okay? So we have two different pieces that we need to look at when we multiply. So the first thing we're going to look at are the coefficients. Remember, coefficients are numbers, like the number 2 or the number 27 or negative 43, negative 1. Any number that is just a number is a coefficient. We also have pieces that we're looking at called variables. Remember, these are letters. Variables are letters, like the letter X. That's the most common we see. Now, it's possible we might have Y's. We could have A's and B's. We could have other letters. Most often we see X, but you will see other letters. So let's talk about the coefficients first. When we have a multiplying a polynomial with another polynomial, we can only multiply coefficients with other coefficients. Okay, that means you can only multiply numbers with numbers. So if we look at this little example right underneath, I have a coefficient of 4 times a variable, that's x, times another coefficient, that's 3. So we can only multiply the coefficients together. So 4 times 3 is 12. And the x doesn't have another x, so we just leave it as x. Okay, so that was a pretty simple example. Let's look at the other piece, the variables, or our letters. So when we multiply our polynomials, variables multiply with other, yep, you guessed it, variables. Okay, that means we multiply the letters with other letters, but they have to be the exact same letter. I cannot multiply an x and a y and make them change, okay? So we can multiply them and put them just together, but we multiply our letters with the other letters, okay? Now, there is something that's going to change when we multiply our variables, okay? It says the blank increases when we multiply our variables. So this is the exponent. Now, we talked about exponents a little bit when we classified them. Remember the exponents? Those are the little letters. So like if I had an x squared, this little piece here is the exponent. So what I'm saying is when we multiply a variable with another variable that it's the same, then that exponent is going to change to a different number. And how it changes is it will add together with the other exponent. Okay? So let's look at this next little example underneath. It says 2 times x times 5 times x. So remember, we said coefficients can multiply with other coefficients. So 2 times 5 is 10. That's what we talked about on the first example. Then we have an x times another x. Okay? So we said we can multiply an x with another x, variables with other variables, and when we do that, their exponent will increase by addition. So the exponent on this variable x is a 1, and the exponent on this variable is a 1. So that means we're going to still have x, but we're going to have how many of them? 2, because we added those exponents together. Okay? So let's look at a couple of examples. All right, so this is just a monomial times a monomial. Hopefully you remember those words from classifying. Remember, monomial means one term. That means we're not having any plus signs or any minus signs in here. We might have negatives, that's okay, but we're not adding or subtracting things together. So we're multiplying one piece with one other piece. Okay? Let's look at the first example. We have a 2. Then a set of parentheses. Remember, parentheses, that means multiply. Parentheses just tell us that we are multiplying. So here on this first example, we have 2 times 3x. So we're going to find our coefficients first, and we're going to go ahead and multiply them together. So 2 times 3 is 6. Then let's identify our variables. This one just has one single variable, it's an x, so we just write that variable. So 2 times 3x is 6x. Let's look at the next one, example 2. Let's look at our coefficients, so -4 and a 2. So we are multiplying -4 times 2, which is -8. Then we're going to look at the variables, x times x. Well, x times x is going to give me another x, but remember we said that has a 1 exponent and that has a 1 exponent, and we're going to add them together. So that means we really have 2 of them now. So -8x squared. All right, let's look at example 3. If you think that you can do example 3, go ahead and take a minute and try to multiply the coefficients together and then the variables and see if you get it right before I do. Coefficient is a 5, another coefficient of -3. So 5 times -3 is -15. Please don't lose the negative. It's not 5 minus 3, it's 5 times multiplying because of that set of parentheses. And then we get the x squared. There's no other variable here, so x squared just stays the same as x squared. It's like saying x squared times 1. It's not changing when you multiply it by a 1. Okay? Number 4, our coefficients are a 2 and a 6, and we're multiplying those, so that's going to give us 12. Oh, this one's fun. Our variables this time are x squared and x cubed. So here we're looking at the exponents. Because those x's are both x's, we're going to add these exponents together. So 2 plus 3 gives us 5. Okay? If that's kind of weird to think about, look at this. I have a 2, and x squared means I have 2 x's being multiplied together. If I have a 6 and then x cubed, that means I have 3 x's. Well, we can see the 12 from the 2 and the 6, but then if we take how many x's we have, we'll count them up. We have 1, 2, 3, 4, we have 5 of them, which is why we end up getting the x to the 5th. Okay, so instead of writing it all out like that, we can just add those exponents together. All right, let's change it up a little bit more. Now we're going to look at taking a monomial. Remember what we said monomials were? That's right, one term. And now we're going to multiply it by a binomial. Do we remember what binomial is? Remember, the prefix bi means 2. So that means 2 terms. Okay? So that means we're going to have one term multiplied by 2 terms. That means we're going to have a plus or a minus sign in here. Okay? So I've got a blank. It says blank the outside to all parts inside the parentheses. So we are going to distribute. Ooh, that's a good word. Does anybody know what that word distribute means? Hopefully you guys are all thinking it means multiply. Distribute is just another mathematical way to say that we are going to multiply something by more than just one thing. So we typically talk about the word distributing when we have a binomial, trinomial, or a polynomial where we've got pluses and minuses going on. So let's look at this first one. Here is the outside piece. Okay, it is the piece that's outside the parentheses. So this means we are going to take the 3 and multiply it to this whole binomial, to the x and the plus 4. So that means we have to multiply it by the x and multiply it by the positive 4. You need to do it in the order, okay? Make sure that you multiply that outside piece by each piece inside the parentheses. So 3 times x. Now we didn't really talk about this yet, but what's the coefficient in front of the x? It's a 1. So 3 times 1 is 3, and x times no other variable is still just going to give me that x. Essentially, if you have a coefficient and a single variable, you can kind of just smush them together and write them as one piece, 3x. Then we're going to look at the 3 times the 4. Now this sign is very important. Make sure that you keep it with that number, with whatever that piece is. So 3 times a positive 4, which gives us a positive 12. This is not 3 plus 4, it's 3 multiplied with 4. So we actually get 3x plus 12. Okay, let's try it again. We have a negative 5 times 2x minus 3. So we need to take the negative 5 and distribute, multiply it to the first term of the binomial. So negative 5 times 2 is negative 10, and an x and no other x is just x. Then we also need to take the negative 5 and multiply it by a negative 3. Oh, be careful. A negative times a negative gives us a positive. 5 times 3 is 15. So we get a negative 10x plus 15. All right, let's look at number 7. Our outside piece here is a 6x, and we're going to multiply it by 6x minus 3. So we're going to distribute, so 6x times 6x. So remember, coefficient with coefficient, variable with variable. 6 times 6 is 36. X times x, remember, this is an x to the first power and an x to the first power, so that means we have 2 of them. Then we're going to distribute the 6x to a negative 3. So 6 times negative 3 is a negative. The 6 times the 3 is 18. And we don't want to forget about the x that we have to distribute as well. So we get 36x squared minus 18x. All right. Negative 2x times, notice how I'm saying times when I see that parentheses, x plus 6. So we're going to distribute negative 2x to the x. So negative 2x squared. And we're going to distribute negative 2x to the 6. So negative 12x. Okay. Take a second. Go ahead and try number 9. Distribute the 2x squared to the 5x and then to the negative 2. When we distribute 2x squared to 5x, we get 10, that's the 2 times the 5, and we get the x squared times x to the first. Notice how that exponent now becomes a 3 because I added them together. 2x squared times a negative 2 gives us a negative 4, and the x squared doesn't change because there's no other x's that we're multiplying it by. All right, the next one, we're going to distribute 3x cubed to 3x. So 3 times 3 is 9. X cubed times x, remember we're adding the exponents, so we get x to the 4th. 3x cubed times 2, well, 3 times 2 is 6. The x cubed doesn't change because there's no other x's. All right. Negative 3 times negative 4x gives us a positive 12x, and negative 3 times a positive 5 is negative 15. And number 12, 2x times 2x squared, 4x cubed, we're increasing that exponent by adding, and 2x times 4x, positive 8x squared. All right, we're going to pause here, take a brain break, and then we will come right back.